Ignition sequence start.
Good morning, and welcome to a look inside the International Space Station's Flight Control Room. These folks, these ones right here, they are the specialists monitoring the operation of all station systems and helping the Expedition 66 crew members as they move through their day's work in orbit. Commander Anton Shkaplerov and his American, Russian, and German crewmates are now just days away from opening the hatch on a new shipment of supplies due to arrive on orbit next week.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. This week, the crew is preparing for a holiday delivery and dreaming of sugar plums. Cargo Dragon is in the final preparations for its targeted launch at 5:06 a.m. Eastern on December 21st. This is SpaceX's 24th cargo mission. Set to launch on a Falcon 9 from Launch Complex 39A at NASA's Kennedy Space Center in Florida. After reaching orbit, the Cargo Dragon will then dock with the station the following day at 4:30 a.m. Eastern. SpaceX 24 will deliver thousands of pounds of goods to the station, including crew supplies and a variety of new scientific investigations, such as 4 new CubeSats, a new protein crystal growth study aimed to improve the delivery of cancer treatment drugs, a handheld bioprinter that will test technology that could one day be used to print tissue directly on wounds to accelerate healing, and several experiments from university students as part of the Student Payload Opportunity with Citizen Science, or SPOCS program. Be sure to follow along on NASA TV, nasa.gov, or the NASA app as we continue to follow this mission leading up to our full live coverage of launch and subsequent docking. Many of us dream of what it would be like to live in space, though very few of us get to actually dream in space. While living on the space station, the crew will experience sunrise and sunset 16 times a day. This can cause disruptions to their circadian rhythm and ability to sleep. The DREAMS experiment aims to study this change in the astronauts' sleep patterns and to examine how their minds and bodies adapt to sleeping in microgravity. ESA astronaut Matthias Maurer will be the next crew member to participate in the DREAM experiment. Maurer will be wearing a sleep headband for several nights that's fitted with dry electrodes and sensors. The headband will observe how he adapts and how his sleep patterns change while in space. The impact of microgravity on sleep is a key challenge facing future long-duration missions to the Moon and Mars. Today's Ask NASA question comes from Grace Ritter on Twitter, who asked, how do astronauts keep clean in space? The crew keep clean in space the same way we do here on Earth. They have daily hygiene activities to brush their teeth, comb their hair, and wash their hands and face. And they even give each other haircuts.
Great job with this. I'm thinking about a third career in hair cutting.
The astronauts wipe their bodies clean using a wet towel and wash their hair by using waterless shampoo. After washing, they will use dry towels to dry themselves off. They also have to complete weekly housekeeping tasks on board the ISS, where they vacuum all air vents and filters and smoke detectors. Then they disinfect and wipe down surfaces that are frequently touched throughout the day by the crew. Areas like handholds, the galley and its tables. Typically, there are 6 hours a week spent on keeping their station home a clean and safe environment. And that's Space to Ground for this week. Thanks for watching. We'll see you next week.
Astronauts on the International Space Station are the lab assistants for scientists conducting research in orbit. And they're also repair technicians when experiment hardware needs some work. Earlier this year, Megan MacArthur wore a mixed reality headset, a HoloLens, to test its usefulness while repairing the Cold Atom Lab. That provided the team at the Jet Propulsion Laboratory with a live astronaut's eye view of the scene and let them insert virtual graphics into the field of view for MacArthur to see.
We are just now joining the meeting that you initiated, and we see your video. It looks good. We feel that the HoloLens will be very useful for real-time guidance as we work to free harness cables so that you can pull out the existing Slice 7 and replace it with the new Slice 7B.
So now we're disconnecting.
We can talk you through most of the steps so you don't need to keep referring to the procedure.
J16 and J17, these little fasteners on either side are non-captive, is that correct?
This activity is called remove and replace, and it involves replacing the existing piece of hardware. It's very important that every step is followed very carefully, and she gets the go-ahead from the team before she proceeds.
Timing-wise, do you want me to try to troubleshoot the HoloLens or continue to disconnect the connectors?
Disconnect.
Okay, so good news, the 564 does fine. I've removed the P16 connector. Then I tried to recover the call. I closed everything I could find to close. Tried to reopen and telling me now no internet connection in an area. So, timing-wise, do you want me to
I think this is going to be really fruitful for the future. This will open up a new branch of physics research in space.
We have a good instrument install and a good demonstration of the HoloLens virtual reality glasses with the remote assist. So thank you again. We're looking forward to powering this up and demonstrating a successful R&R. We'll talk to you soon. Thank you. Bye.
The microgravity in Earth's orbit makes the International Space Station a one-of-a-kind spot for scientists who want to find out how natural forces function without the influence of gravity. In this Speedy Time segment, astronaut Jack Fisher uses a few simple tools to demonstrate what happens to water in space when there's no pull of gravity.
Today we're going to look at one of the coolest parts of having experiments on the space station. It's because we can separate one of the most dominant forces, gravity, on a lot of different models. A great example is water. Water is pretty much dominated by gravity on Earth, but there's other forces at work that if we understand better, we can have a better model and make greater discoveries. Things like surface tension, capillary action. I'm going to show you today by taking this wonderful bottle, repurposed from a condiment, and blowing into it. When I displace the fluid with air, it will come up the straw and cover my face.
Supporting scientific research and providing benefits to people on Earth are two of the overarching goals of the International Space Station program. Another big goal is encouraging the growth of a commercial space economy. And in the last few years, the Space Station program has been making good progress on that front, too.
The International Space Station has proven to be a one-of-a-kind laboratory. Microgravity conditions allow for experiments impossible to duplicate on Earth. New science, new knowledge. The station has also proven to have the capacity to serve as an incubator for new business, accelerating the development of a new space economy in low Earth orbit. The business of doing business on the International Space Station has become a primary focus of NASA in the last 10 years. Mike Reed is the manager of Space Station Business and Economic Development for NASA at Johnson Space Center. He explains how businesses are enabling research. Supporting all of the research activities on station is becoming a significant activity in and of itself. Companies like Bioserve, TechShot, Space Tango, and others operate over 20 commercial research facilities housed on the station. Scores of companies provide services as payload developers, helping researchers translate their experiments into hardware small and light enough to be transported to and housed on the station. All of these commercial activities support business models and expand the numbers of entities with experience in conducting business in space. As NASA increases the opportunities for companies to perform research on the space station, it's likely that the number and types of companies taking advantage of those opportunities will also increase. That in turn will help keep the partnership between NASA and business thriving. Reed notes, soon we hope to see private astronauts as part of NASA's LEO commercial development program. Some of those may be researcher astronauts. That is, researchers who work directly for a company and are trained to come work in the station during private astronaut missions. To enable the beginning of development for a next-generation, commercially built and operated low Earth orbit research platform, the space station is hosting new commercial modules. The NanoRacks Bishop airlock became operational in February 2021, and Axiom Space plans to launch a module to expand the habitable volume for research and other activities on the station. NASA's commercial resupply and commercial crew programs are also enabling multiple companies to develop and operate the next generation of spacecraft and launch systems. This commercial transportation to and from the station has fueled the growing market share of U.S. launch providers in the world marketplace, and is providing expanded utility, additional research time, and broader opportunities for discovery for NASA's mission of space exploration. The innovative use of public-private partnerships employed to support station research is becoming the template for NASA's new exploration initiatives. The Artemis program has the goal of landing the first woman and first person of color on the surface of the moon. In addition, Artemis plans include establishing a lunar outpost built by private companies, and eventually harvesting resources from the moon. Doing business in space has become one of the fastest growing businesses on Earth. The space economy has expanded by over 60% in the last decade, and is now valued at roughly $400 billion. That commercial success is matched in importance by the knowledge gained from private research conducted on the space station. It's knowledge that spans hundreds of disciplines and will help millions here on Earth, as well as those traveling beyond the reaches of our planet for years to come. For more information about how private companies can conduct their research on the space station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
The astronauts who flew to the International Space Station on NASA's SpaceX Crew 3 mission have been working together for more than a year now, so you'd think they'd have gotten to know each other pretty well. Well, watch as Rajachari, Tom Marshburn, Caleb Barron, and Matthias Maurer all declare who on the crew is the funniest and who has an annoying habit. Find out which of the crew members is the most perspicacious and who said smorgasbord and why.
Raja is super fast at analysis.
Funny, caring, and competent.
And he's super talented, super skilled, a lot of fun to work with.
Tom Marshburn, I would say creative and a teacher.
The silent, quiet part, but with a lot of experience.
Wise.
Kayla is a great communicator.
Perspicacious.
So much experience being in confined environment, keeping calm.
Matthias is a constant innovator.
Inventive.
Innovative.
The funniest must be Grinder. That's Raja.
Grinder.
Roger.
Tom's he doesn't talk about it a lot, but he's done a lot of crazy mountain climbing.
Tom Marshburn is the most adventurous.
Good question, Matthias.
I think that would be me.
Primarily looking out the window with each of them individually and just doing stupid human tricks together.
Enjoying the time off work, watching down towards our beautiful planet and just sharing our dream.
Probably hanging out in the cupola and just looking down on the Earth.
I think coming up with some crazy concoctions made up of expired food that we turn into a smorgasbord. I think Kayla might win if we spanned it out over time because she has the ability to sustain snacks for a very long period of time.
It's like Kayla loves a big breakfast.
Probably me or Grinder, unfortunately.
Probably Kayla.
Kayla.
Probably Tom. I don't know. We should have one. Find out.
Probably talking to myself when I'm thinking.
I think I've started having more inner monologues or things I'm saying under my breath that I got from Tom Marshburn.
I should ask them that, though. Let me know what they say.
Probably me.
Probably me.
That'd be me.
That's me.
The lifeblood of the International Space Station's cooling system is ammonia, which carries heat from the vehicle and its hardware systems out to the radiators to be dissipated into space. If the cooling system sprung a leak outside, it used to fall to spacewalking astronauts to find the location of the hole. But not today. The folks at NASA's Exploration and In-Space Services Projects Division at the Goddard Space Flight Center developed a leak locator tool and an exterior storage device for it that makes repairs possible more quickly and with less astronaut involvement.
How do people live in space? One major factor is making sure everything is just right, including the temperature. People have lived on board the International Space Station continuously for over 20 years, something that is made possible through its cooling system. Liquid ammonia in specialized pipes throughout station acts as a coolant to keep the temperature habitable for humans. Every so often, the pipes will spring a small leak, and the ammonia escapes outside the ISS. Occasional leaks are expected and typically pose no threat to astronauts, but they're inefficient, could become a bigger problem if left unattended, and can be a hassle for astronauts to manually locate the leaks via spacewalk.
The ISS program recognized very early on that ammonia leaks could be a big problem, and with the large radiators, that they would be something that happened, every couple of years. What they would do is basically monitor pressure in gas lines in various parts of the system, and using those measurements, they're able to isolate a leak to some segment of the overall system. But they don't have the capability without REL of pinpointing where the leak is.
QREL, the Robotic External Leak Locator, a toaster oven-sized tool that can detect ammonia leaks outside of station. REL can locate an ammonia leak in a fraction of the time required for a manual search. Deployed by station's robotic arm, REL uses two instruments and plays a game of hot and cold.
The REL, it's a tool that includes a mass spectrometer and a total pressure gauge. So a pressure gauge is pretty straightforward. It just tells you the local pressure where it's pointed, and pressure is equal to the number of molecules that are there. The mass spectrometer is a little bit more complex. It not only tells you how much gas is leaking out, but it also tells you what that gas is.
Using these instruments, REL is able to detect the gases in its surroundings and follows the trail of ammonia until it finds the highest concentration, thus revealing where the coolant system has sprung a leak. Following the success of the first REL tool, launched in 2015, a second was launched in 2019. The REL tools were initially stored inside of station, which meant a lengthy and precise procedure to get them from storage out of the GEM airlock, picked up by Dexter for leak locating, and finally returned to the airlock. That's where RITS comes in. The Robotic Tool Stowage, or RITS, acts like a garage or robot hotel. It is affixed to the outside of station and has 2 ports for each of the REL tools to reside while not in use.
The RITS was launched in December of 2019, so it's been up on space station almost a year now. It was just kept in storage. It launched up in a kind of a foam box, and it was brought inside the space station. And just in July, the astronauts unpacked it, and they installed the leak locator tools inside it, and they got it ready. And then there was an EVA, the spacewalk was performed to install it on the outside of space station.
RITS and REL are just another example of how robots and astronauts can work together to enable a sustained human presence in space. Robotic tools are easy to use, efficient, cost-effective, and safe.
One thing I want to note is that the robotic servicing is all done by controllers on the ground. So having the tools outside, we don't need to involve the astronauts on the space station at all. It kind of saves them time, one less thing they have to worry about.
While the REL units, stored cozily in RITS, are utilized to keep astronauts safe on station, our team continues to develop and build on this technology on the ground.
So one thing I'm excited about as far as the RITS technology is, and this has kind of been an evolution of tool stowage designs that we've built. So this is going to be very, very valuable anytime you're going to have robotic servicing, which is going to be increasingly more frequent for exploration in lunar orbit, and also if there's any outposts on the way to Mars. We're going to see increasing amount of robotic servicing, and the robots are going to need specialized tools and ways to secure them safely and keep them protected.
As you can imagine, the ability to characterize the type of gas present and the ability to locate leaks have applications beyond just space station. Anywhere there can be a human habitat, like the Moon or Mars, a leak locating tool will probably be a must. Additionally, robotically characterizing gases in places we've never been before can help us learn more about new environments, laying the groundwork for future exploration.
Always nice to add a new piece of capability to the space station, and there's always a capable group of folks behind it, but this one is particularly special. Dave Parker battling ALS. Wonderful to see a project that he's been involved with from the beginning. To see these lights illuminate. Congratulations, Dave. Congratulations, Team Dave. Team Dave.
One of the best parts of being an astronaut aboard the International Space Station, or so I'm told, is looking out the windows to a living color view of planet Earth. In this demonstrations episode, astronaut Randy Bresnik discusses the station's role as an Earth monitoring and diagnosis station, while showing some of the amazing images he and his colleagues have captured from 250 miles straight up.
Hello, I'm astronaut Randy Bresnik. Want to know one of the best parts about being an astronaut up in space? Our view of the Earth from the International Space Station is absolutely spectacular. And viewing the Earth from space is a big part of our job. In addition to many other important functions, the International Space Station serves as a global monitoring and diagnosis station where we can conduct observations across the globe, aimed at understanding and resolving environmental issues we face on our home planet. Let's have a look. The space station offers a unique vantage point for observing the Earth's ecosystems with hands-on and automated cameras and image capture equipment. These tools enable astronauts to both observe and explain what they're witnessing in real time. The image capture equipment on the space station also provides input to personnel back on Earth, working to program the station's automated Earth sensing systems, providing flexibility and an advantage over sensors on unmanned spacecraft and satellites. Scientists and researchers find this especially useful when unexpected natural events such as volcanic eruptions, earthquakes, hurricanes, fires, and other natural disasters like floods occur. Through existing international and interagency partnerships fundamental to the International Space Station, data sharing that can benefit people around the world is facilitated, promoting international collaboration on a range of Earth observation activities. A wide variety of Earth observation equipment can be attached to the space station's exterior, like I did on one of my spacewalks. Several instruments have already been installed, and researchers from around the globe are proposing additional payloads to install. In continuing to use a combination of crew-operated and automated Earth observation payloads, the space station collects crucial data on the global climate, environmental change, and potential hazards to the health of humanity and our home planet. The Window Observational Research Facility, or as we call it, the WRF, provides a highly stable internal mounting platform to hold cameras and sensors. With the WRF, the high-quality optics of the nadir, or the bottom viewing window of the space station, allows us to look straight down onto Earth. Do you want to participate in some of our Earth observation missions? Come join us. Check out the Sally Ride EarthCam website. Go to earthcam.org and follow the instructions to sign up. And have a look at some of the spectacular Earth views from space and see what you can identify. You can also try the activity in the link we provided in the description of this video. Thanks for joining me. See you all next time.
If you want another look at any of the stories we showed you today, go over to YouTube and Facebook at those addresses right there, and you'll find them all, along with lots of other great features on a variety of NASA topics. If you're looking for good conversation about human spaceflight, check out Houston We Have a Podcast, our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan learns about all of the elements in play in NASA's Space Communications and Navigation Program and the NASA missions that system supports today and in the future. Go to nasa.gov/podcasts for this week's episode and all our previous episodes. You'll also find the full library of all the NASA podcasts, and all of that is also available on Apple Podcasts, Google Podcasts, and SoundCloud. You can get the latest from all over NASA delivered to you every week when you go to nasa.gov/subscribe and sign up for the NASA newsletter. You will thank me.